In this video, I'm going to determine if the vector field f of xyz is equals to minus 2 exponent of 2x cosine yi plus exponent of 2x sine yj plus 5 exponent of 2zk is conservative. So we are checking if that vector field there is conservative. A vector field f is said to be conservative if the curl of f gives us the zero vector. So what we have to do there is we have to evaluate the curl of the given vector field. The curl of a vector field f is given by grad cross f. In this case, we are having three variables there. So our grad is the one which has three components there: partial derivative with respect to xi, partial derivative with respect to yj, plus partial derivative with respect to zk. So for our curl there, it will be the determinant of the matrix which has row ijk, the second row with partial derivatives, then the third row with the components of that vector field: minus 2 exponent of 2x cosine y, exponent of 2x sine y, then the 5 exponent of 2z. So I will now go on and evaluate that determinant. And to evaluate that determinant, I'm going to use the first row. So look at the first element of that first row. I'll close the row and column containing that element, and then take the determinant of the uncovered elements. So for the determinant of the uncovered elements there, we are having partial derivative with respect to y of 5 exponent of 2z, then minus the partial derivative with respect to z of exponent of 2x sine y. So I'll just write those derivatives there: partial derivative with respect to y of 5 exponent of 2z minus partial derivative with respect to z of exponent of 2x sine y I. Then go on to the next element. We are now looking at the j there. Close the row and the column containing the j. And we should note that the j there, when we are looking at the sign factor array, the j is sitting on a negative. So we now take the determinant of the uncovered elements: partial derivative with respect to x of 5 exponent of 2z, and then minus the partial derivative with respect to z of minus 2 exponent of 2x cosine y. So for the j there, we are saying is minus then partial derivative with respect to x of 5 exponent of 2z minus the partial derivative with respect to z of minus 2 exponent of 2x cosine y j. I now move on to the last element of the first row there. We are now looking at the element k. Close the row and the column containing the k. Then take the determinant of the uncovered elements. We are looking at partial derivative with respect to x of exponent of 2x sine y, then minus the partial derivative with respect to y of minus 2 exponent of 2x cosine y. And the k, when we are looking at the sign factor array, the k is sitting on a positive. So we would have plus the partial derivative with respect to x of exponent of 2x sine y minus the partial derivative with respect to y of minus 2 exponent of 2x cosine y k. I now go on and evaluate these partial derivatives here. The partial derivative of 5 exponent of 2z with respect to y, it gives us a 0. The partial derivative of exponent of 2x sine y with respect to z, it gives us a 0. So we have 0i there. Then for the next part here, we are looking at this one here. The partial derivative of 5 exponent of 2z with respect to x, it gives us a 0. The partial derivative of minus 2 exponent of 2x cosine y with respect to z there, it gives us a 0. So our result there will be minus 0j. Then I go on to the next part there. If we are looking at the partial derivative of exponent of 2x sine y with respect to x, it gives us 2 exponent of 2x sine y. Then for this partial derivative here with respect to y, what it will give us there is the minus 2 there is multiplied by a minus sign, so it will be 2 exponent of 2x sine y. Then we would have this other minus sign. So our result there will be 2 exponent of 2x sine y minus 2 exponent of 2x sine y k. But if you look at this part here, 2 exponent of 2x sine y minus 2 exponent of 2x sine y, it gives us a 0. So our result there would be 0i minus 0j plus 0k. So what we are having there is the k there is 0i minus 0j plus 0k. That is just the 0 vector there. And if you still recall, when you started, we said that a vector field F is said to be conservative if the curl of F is the 0 vector. In this case, we are having the curl of F is giving us the 0 vector. Therefore, this given vector field is conservative. So that's the solution there. The vector field is conservative.